things that like to stay the same. Scientists call this inertia. Picture this. Let's say you have a toy car. If your toy car is still and not moving, it will stay forever until you or your friend push it. Now let's say your toy car is moving. It will keep on rolling and rolling until something like a wall or your hand stops it. Basically, it means that to make something start moving or stop moving, you always need a push or a pull force. Newton's second law. This law tells us how a push force, the weight of an object mass, and how much it speeds up acceleration are all connected. Let's use the toy car example again. Now let's say we have two friends. One person pushes the car from the front and another person pushes the car from the back. Let's say the person in the back is you. If you use a little bit of force to push the car, it will move slowly. Now, imagine your friend pushes the car with a big force. What happens to the speed of the object? Of course, the car will speed up. So if you give it a huge push, it will speed up more quickly. That's the first part of the second law. Now imagine this. Let's say you have a small light feather and you have a huge big rock. If you push both the feather and the rock with the same exact gentle push, which one would speed up more? What do you think? If you say feather, then that's exactly right. The feather will speed up much more because it's so light. So the second law says that weight, mass, and speed of acceleration are opposite. If an object is light, like the feather, it's easy to push, so it gets a huge speed up. But let's say if an object is heavy, like the rock, it's hard to push, it gets a tiny speed up. If I were to summarize Newton's second law, I would say that Newton's second law states that weight, mass, and speed acceleration are opposites. And if I was to talk about Newton's third law in simple words, I would say every push gets a pushback. You can never just push something without it pushing back on you. For example, let's say you push a door. The door pushes back on your hand. Or if you're standing on a floor, your feet pushes down on the floor and the floor pushes up on your feet, so you don't fall through. Basically, for every action pushing down on the floor, there's an equal and opposite reaction. As I'm saying this, I found an easy example using my pen. If you link this example to what I said earlier, then for every action, there's an equal reaction.